All right, let's do an example that involves cotangent and tangent, and we're going to see that this one has a one answer. Okay, actually, the general rule is, if it's tangent or cotangent, it will have one formula for an answer. If it's not, you're probably going to need two formulas for sine, cosecant, secant, and sine, cosecant, secant, and cosecant, and cosine. Okay, so what is cotangent inverse of square root of 3 over 3? We want to write a general formula for that. This is already, well, this is not in terms of sine, cosine, or tangent, so we need to convert it. Remember, cotangent inverse is tan inverse of 1 over x. So we're going to plug that in. We know before that that's going to give us square root of 3, so we just need to figure out where on the unit circle does tangent equal square root of 3. Here's our special tangent unit circle. It's going to be true here, which is at pi over 3. It's going to be true down here at 4 pi over 3. Okay. Now we're going to figure out our next two angles by adding 2 pi to this one and adding 2 pi to that one to figure out if this time we have one general formula. Okay. So pi over 3 and 4 pi over 3 are 2 points on the unit circle where tangent equals square root of 3, which means cotangent, going back to our original question, would be square root of 3 over 3. Remember, inverse trig function means your answer is angles, not a ratio. You're given a ratio, you want to figure out angles. So let's add 2 pi to pi over 3, and we end up with 7 pi over 3. So that will be the third angle in our sequence. Let's add 2 pi to 4 pi over 3, we get 10 pi over 3. And guess what? These have a common difference. Our first four terms, angles in the sequence, which will all give us cotangent of our cotangent ratio of square root of 3 over 3. If you look at the numerators, they all have a common difference. The coefficients have a common difference of 3. So we can use one formula for this one. Again, that's going to be true for tangent and cotangent. Plug in 3 in for the common difference. 1 is our first coefficient. 1 plus 3 and minus 3 is 3 and minus 2. Therefore, our final answer is 3 and minus 2 pi over 3 will give us every single angle in existence where cotangent is equal to square root of 3 over 3, namely cotangent inverse of square root of 3 over 3 equals all of these angles. So you just plug in an n value, any n value, and it will give you an angle where this is true. Again, this also works for negative angles. If you were to plug in, say, even 0 for n, you'd get negative 2 pi over 3. And if you go at the unit circle and think about negative 2 pi over 3, let's see here, you would actually start right negative 2 pi over 3, so you would start right here at 0 pi, negative 2 pi over 3, this is negative pi over 3, negative 2 pi over 3, and voila. You do x over y, and you'd still get cotangent is equal to negative square root of 3 over 3. So that formula works for both positive and negative angles. That's it for this example, finding a formula for inverse trig functions. If you have any other questions about it, let me know.